Yeah, welcome. The topic we'll be discussing in this lecture will be implementing the single linked list. Okay, so there are different types of linked list. The first type of linked list that we'll be discussing is single linked lists. Okay, there is also something called as doubly linked list, and also there is circular linked list. Okay, so before that, in this class we'll be discussing about singly linked list. Okay, so in a single linked list, it's a basic version of linked list which contains set of nodes. A node contains two ports, a data port and a pointer port. The pointer port of the each node will point to the next node. Okay, so this is how the single linked list is represented. Okay, so there will be a set of nodes, and every node will have two ports, data port and a pointer port. And the data port will have some data port can have either one data or more than one data. Okay, for example, data port may include name of a person, age of a person, his height, weight, like that. It may also include more than one data items. It is not that it should have one data item. Okay, and the pointer port will always point to the next node. Okay, the pointer port of the last node will point to null. Okay, so if this is the last node, then its pointer will be null. So every other node will point to the next node. So there is something we need to point to the first node. So for that we'll be using a pointer called as header. So header is a one kind of a special pointer which will point to the first node. Header, or just we'll say head. Head is something which will always point to the first node. Okay. So this is how we define the singly linked list. Now let us see how can we create a single linked list, and how it can be implemented in C programming, and various operations on a single linked list, like inserting an new node, or deleting an existing node, or displaying the contents of the linked list of all the nodes contents. All these things we'll be discussing here. Okay, fine. So basically we should create a node. So we should create a data structure for the node. So you take a typical node. Node contains what? It contains a data port and a pointer port. And this pointer is what type of pointer? This is a pointer which should point to another node of the same nature. Okay. Okay. So how can we do that? So this can be done in a better way by using structure, right? So we are defining something called as, so we are creating a node. This node is a structure. Okay, fine. And this structure contains two data items. What are they? One is a data which is of type integer, another one is a pointer. Next is a pointer. Pointer of what type? Pointer of type struct node. What is struct node? Again, struct node is a combination of two things, data and a pointer. Okay, so this has captured the features of a node in an appropriate way, because this is how we define the node. A node has a data part and a pointer part which can point to the another node of same type. Okay, so this is how we define a basic structure. Using this, we can create the basic components of a linked list, which is nothing but the node, right? So in this linked list, our data part has contain only one data item of type integer. If you want that, you can include more than one data item. Okay, for example, here I can include age, int age. Okay, then it means there are two data items, and okay, so totally this entire data we call it as, we consider as one group. Okay, this data part contains two things. What are they? Int data and int age. Like that, you can have more than one data items also. Okay, but it should have a pointer which should point to the next node, right? So this is how we define this. This is how the node data structure can be implemented, right? Next. So you can see here, as we already discussed, the head node should always point to the first node. So we create like this struct node star head. Head is a pointer. Now as of now head is a pointer which can point to an which can point to an uh, uh, which can point to the address of type struct node. Okay, head is a pointer which can point to the address of type struct node. Currently it is not pointing anywhere. Currently it is not pointing anywhere. Okay, but later in the when the program proceeds it will point somewhere. Let us see that. Fine. Okay, fine. So first let us see how to add elements to a node. Add elements to the linked list. Let us assume that initially our linked list is empty. That is the linked list. So far we have did only this much coding. Okay, so it means that there is no node at all. There is no node at all. We want to add nodes to the linked list. So how can we do that? So that can be done by this particular function. See here, see this function. The name of the function is add node. It's a void. It does not have any return type. It takes one value as argument. What is this value? This value represents what should be the data part of the node should have. Okay, this probably we can take as input from the user. Okay, say for example what I'm trying to say in the sense, okay, say for example we can ask the in the main function. Okay, in the main function, say this is the main function of the program. In the main function, say for example I'm not taking any user input. For simplicity I'm writing like this, int I. Okay, for I is equal to 0, I less than 5, I plus plus. Okay, here what I'm going to do is I'm going to create 5 nodes. For that I'm going to call this add function. Okay, this add function will create nodes with the appropriate value in the data part. Okay, what is the add function protocol? You can see it needs one integer. That's it. It needs one integer. Okay, so what I will do here is I'll just say that add node of I plus 1. That's it. Okay, so this loop will repeat for 5 times. When I is 1 it will call add node 1. When I is 2 it will call, when I is 1 it will call add node 2. When I is 2 it will call add node 3, like that up to 4. When I is 4 it will call add node 5. Okay, now it means that we want to create a new node whose data part should have the value 1. That is the meaning. In the next iteration again we want to add another node to the list such a way that its data part will be 2. Like that we want to add 5 nodes, such a way that the first node will point to the second node, second will point to the third, third will point to the fourth, and fourth will point to the fifth. The first node's data part will be 1, second node's data part will be 2, third node's data part will be 3, fourth node's data part will be 4, and fifth node's data part will be 5. Okay, so let us see how that can be implemented, right? So now so initially add node function is called with I value, with value 1, right? With the value 1 it got called. Okay, fine. Let me make this small. Yes. Okay, fine. So here we are creating 2 more pointers for structure node for our convenience. Okay, so this value is 1. We are creating 2 more pointers. One is TRAV. TRAV is for traversing. Currently our list contains no nodes, 0 nodes. Okay, otherwise if there is some nodes are there, then you may want to travel from one node to another node. For that this traversal pointer is being used. And then there is another pointer temp. Temp is nothing but which is used to create a new node. Okay, here we want to add node, means you want to create a new node and then add. So that new node will be created by using temp pointer. Okay, so both of these are pointer to memory locations of type struct node. Okay, fine. So here what we are doing, traverse is equal to head, because if you want to traverse through the linked list, from which node you should traverse? From the first node. Okay, So how will I get the address of the first node? Already we discussed that head will always hold the address of the first node. Okay, head will always hold the address of the first node, so that we are telling traverse equal to head, which means that traverse also will point to the first node. But as of now, what is the first node? We have not created any first node. So here we will add one more statement. Initially head will be null. Okay, initially head will be null. When there is no node in the linked list, head will be null. Okay, let us add this statement also here. Okay, so as of now our linked list does not have any node, so head is pointing to null. So what will be traverse? Traverse is assigned to head. Head is null, so traverse is also null. Traverse is also null. That is, currently there is no node in the list at all. There is 0 nodes. Okay, fine, it's okay. Next, temp is the new node which temp should point to the new node which we are going to create. So how to create a new node? So we are creating like this: struct node star malloc size of struct node. So this will create a new node, and that node will have a data port and also a pointer port, and that node starting address will be pointed by temp. Okay, so temp is a pointer here. Temp is a pointer. So this is the first node we are creating, and this first node initially, so let us assume the starting address of this node is say 2000. Okay, see, it has how many entries? It has 2 entries, a data port and a pointer port. Okay, say let us assume this data port takes 4 bytes, say this pointer takes 8 bytes, so it needs totally 12 bytes. Okay, so 2000 to 2011 it will occupy. 2000 to 2011 it will occupy. Okay, and the starting address 2000 will be stored in temp, which means that temp is pointing to this particular new node just which we have created, right? Okay, and currently we have only one node, so where this next should point? This next should point to null, because this is the first node we have created, there is no other node. So temp arrow next is equal to null, so this is pointing to null. Okay, fine. Then see what we are checking: if traverse is equal to null. When traverse will be null? Traverse will be null if head is null. When head will be null? Head will be null if this is a first node. Okay, so this is the condition to check whether whether the node which we are trying to add is the first node. Okay, if this is the first node that we are checking. If this is the first node, okay, then what we are doing is, okay, if this is the first node, then what we are doing is we are just saying that head is equal to temp. That's all. We are just saying that head is equal to temp. Previously, what is head? Initially, what is head? Head in the previous slide we have seen head is null. Previously, head is what? Null. It is not pointing anywhere. Okay, and we are checking here whether traverse is equal to null. When traverse will be null? If head is null, traverse is null. If head is null, what is the meaning? Then there is no more node previously. Then this is the first node. Okay, and if this is the first node, this should be pointed by whom? Head. So we are saying head is equal to temp. What is temp? 2000. So 2000 will go into head also. So this null will be overwritten by 2000. Okay. Now where head is pointing? Now head is pointing to the first node. Okay. Fine. So this is how the first node is added. Okay. Here we will add one more statement which is being missed. Data part we are not temp arrow data. Okay. Temp arrow data is equal to val. Okay, because that value also should reflect in the appropriate node. Okay, temp arrow data is equal to val. So what is val? Val is 1 currently. So this is 1. So we created first node with value 1. Its next is pointing to null. Head is pointing to the first node. Right? This will execute. This else part now will not execute. Okay, because this will execute only if this is not the first node. Currently this is the first node, so the else part will not execute. Okay, here is the closing bracket of the function. Right? So this is currently we have inserted one node, right? Fine. So this is the case when you call this particular, what you call, the function for the first time. Okay, yeah, here it is. Okay, this is in the first iteration. So let us assume the second iteration. What will be I value? I value will be 1, I plus 1 will be 2. Okay. So in the second iteration, the same function will be called with 2 as the value. With 2 as the value. Okay. Now also we do all these things. Traverse is equal to head. Now what is head? Head is 2000. Okay. So traverse also will be 2000. That is where is there is another pointer. Okay, we have two pointers, right? Traverse. So there is another pointer, traverse. So traverse is equal to head. Traverse is equal to head. So what is head? Head is 2000 currently. So traverse is equal to head. So it means that traverse is also pointing to the first node. Okay, fine. Traverse is pointing to the first node. Now temp is equal to struct node star malloc size of struct node. So now we are going to create another node. So temp no more will point to this node here, rather again another fresh node is created. Again one more node is getting created. Okay, so a fresh node is getting created. So this will create a new node and temp will point to this new node now. Okay, let us assume this node's starting address is say 3000. Okay, each node, the adjacent nodes will not will not be stored in consecutive locations. They can be stored anywhere, right? So if temp is if the starting address of the new node is 3000, then temp will hold 3000. Then temp will hold 3000, which means that now temp is pointing here. Okay, and then we are saying temp arrow next is equal to null, because always new node will be added in the last. Okay, so that is the last node. That is going to be the last node. So its next will be null. Okay, so its next is null, and temp arrow data is equal to val. Now what is val? Val is 2, so its data part becomes 2. Okay, and now we check if traverse is equal to null. No, this time traverse is not null, because there is one node already and head is pointing to that. So traverse is pointing to which node? Traverse is not null. Basically traverse is not null, so the else part will execute. What the else part says? What the else part says? While traverse arrow next not equal to null. Okay, so traverse is pointing to the first node. While the traverse arrow next not equal to null, traverse is equal to traverse arrow next. But what is traverse? Traverse is pointing to the first node. What is first node's next? Is it null or not? Yes, it is null. Okay, so this loop part will not execute. It will just come out. Okay, after coming out, what it will do? Traverse arrow next is equal to temp. What is traverse arrow next? This. Okay, traverse arrow next is first node's next pointer. That will be equal to temp. What is temp? Temp is what? 3000. So this null will be now replaced with 3000. This null will be now the first node's null will be now replaced with 3000. It means that the first node's traverse arrow next points to the first node. Traverse arrow next represents first node's next pointer. It means that the first node's next pointer is now pointing to the second node. So you have created the second node, right? Great. Okay. Similarly, when the loop executes for the third time, that is when I is equal to 2, it will call add node of I plus 1, that is 3. So now the val part will be 3. Okay, val part will be 3. Again we are creating all these things, travel, temp, everything. Now traverse is equal to head. Head will always point to the first node. Head pointer we never change. Okay, initially when no nodes were there, head will be null. Afterwards head will be always pointing to the first node. So head is pointing to the first node. Traverse is equal to head. Traverse also now pointing to the first node again. Okay, traverse also pointing to the first node. Then we create a new node. So now temp is not pointing here. Now we are one more new node we are creating. Okay, so no more temp is here. No more temp is here. Now the third node we are creating. Okay, now the third node we are creating, and by using temp is equal to struct node star malloc size of struct node. So this will create a new node with the data part and a pointer part, and temp will refer there. and temp will point there. Okay, let us assume this new node's starting address is 4000, then temp will point to this 4000. Okay, then temp will hold the address of that particular new node, which is 4000, which means that temp is pointing to this particular new node which we have created right now. Temp is pointing here. Okay, again temp arrow next is null, because whenever you add a new node, we add the new node as the last node. So last node's next should be null. So temp arrow next is null. Temp arrow data is val. What is val? 3. So this becomes 3. Then we check if traverse is equal to null. No, traverse is not null because head is not null. So this is not the first node, so the else part will execute. While traverse arrow next not equal to null. What is traverse? Traverse is pointing to the first node. First node's next, is it null? No, it's not null. Then traverse is equal to traverse arrow next. What is traverse arrow next contains? This is traverse arrow next. What it contains? 3000. So that 3000 will be now stored in traverse, this pointer. So no more this will be 2000, it will be now 3000. Okay, which means that now the traverse pointer is not pointing to the first node, rather it is pointing to the second node. Okay, now the traverse pointer is pointing to the second node. Okay, it's pointing here. Okay, fine. Then again we check, while traverse arrow next not equal to null. Now traverse is pointing to the second node. Is second node's next is null? Yes, it is null. Okay, if it, then it will come out. After coming out, what it will do? Traverse arrow next is equal to temp. What is traverse? Traverse is second node. What is second node's next? This part, which is equal to temp. What is temp? 4000. So this null will be now replaced with 4000. Okay, it means that now the second node is pointing to the third node. Okay, fine. So like this, it will add more and more nodes. Okay, this is how we add nodes to the linked list. Okay, this is how we add nodes to the linked list. Okay, I think it's clear. Fine. Okay, now after adding nodes, we may want to display the nodes. Okay, we may want to display the nodes. For that, we can use this particular simple logic called display, which will just display all the nodes. Okay, so there is a function void display. Here also we are creating the traverse pointer and we are making traverse to point to head. Okay, in our previous case, if we see 3 nodes we created, or say 5 nodes we created, as per the program we created 5 nodes. First node is pointing to second, second is pointing to third, okay, third is pointing to fourth, and fourth is pointing to fifth. Okay, so here I will draw the fourth and fifth. So this is fourth and this is fifth. Okay, so these are the 5 nodes that we have, and the fifth node, obviously that fifth node's next will point to null. Okay, now initially what we are doing, traverse is equal to head. Head will always point to the first node. Okay, so traverse also now pointing to the first node. Okay, okay, head is pointing to the first node. Traverse is equal to head, so traverse is also pointing to the first node. Okay. Right, so if head is 2000, then traverse will also 2000, then that means that the first node starting address is 2000. Okay, then what we do here, first node starting address is 2000. While traverse not equal to null, print of %d arrow traverse arrow data. Is traverse is null? No, it's not null. So then what we do, print of %d traverse arrow data. What's the first data here? Traverse is pointing to the first node, so what is its data? 1. So it will display 1, and followed by, it will display this arrow mark. Okay, that is first node is going to point to some other node, like that. Okay, and then what we are doing, traverse is equal to traverse arrow next. So traverse arrow next means traverse arrow next, where this is pointing, say this is pointing to the address 3000. Okay, traverse arrow next contains the address 3000. So now traverse will become 3000. It's no more 2000, it is 3000. So currently traverse is now pointing to the second node. Traverse is pointing to the second node. Again we check, is it null? No, it's not null. Then display the data part. What will be its data part? 2. So 2 will be displayed, right? Again traverse is equal to traverse arrow next. What is its next? Maybe its next may be pointing to 4000, because third node starting address may be 4000. Okay, so this is 4000, right? This is 4000. So now traverse value is what? Traverse is equal to traverse arrow next. So it means this is no more 3000, it is 4000. Okay, again we check, is this null? So now traverse is not pointing here. Now traverse is pointing to the third node. Is it null? No, it's not null. So display the value. So what's the value? 3. Okay, like that it will display all the other nodes also. Okay, finally after displaying 5 nodes, 4, okay, third will point to the fourth node, fourth will point to the fifth node. Okay, finally when traverse is pointing to this particular last node, okay, then we display 5. Okay, after checking 5, traverse will become traverse arrow next. Now what is traverse arrow next? Null. So traverse will become null. At last it will become null. So then again next when you come and check, while traverse not equal to null, this is failed. It is null. Okay, so as it is null, it will come out. Okay, after coming out, what we should display? Null we should display, because fifth is pointing to where? It is pointing to null. Okay, so this is how we can display the contents of an linked list, right? So here in that notepad code I will add. Okay, so we added 5 nodes. Okay, initially what we did, we added 5 nodes. Okay, after adding 5 nodes, let me display the contents. Just by calling the function display, it will display all the contents of the, that is 1 2 3 4 5, whatever it may be, right? Okay, this is how we add nodes to the linked list and we display the contents of a linked list. Next, let us try to understand how to insert a new node after a specific node in the linked list. How to insert a new node after a specific node in the linked list. So here we need 2 things. Say already our linked list contains like this. First node is pointing to second, second is pointing to third, third is pointing to fourth, fourth is pointing to fifth. Okay, say that now I want to add a new node. So let us assume that new node's data part contains 35. Okay, say I want to add this new node after the node 3. Okay, after the node 3. Okay, then how the linked list will change? The linked list should change like this. Now 3 is next should point to 35, and 35 is next should point to 4. Okay, so this is what is called as insertion. So whenever you want to insert, what should happen? The previous node, so the whatever the node you want to insert, that is called as new node. That is called as new node. Okay, this is the new node which we want to insert. Okay, right, and the previous node should point to the new node, and the new node should point to the previously where the previous node is pointing. Okay, so these 3 changes we have to do. Okay, fine, right. But there is another few things which you should observe here. The first thing is, what if the user is trying to insert? What if the user is trying to insert when there is no node in the list? Okay, assume that the linked list is empty. So normally when the linked list is empty, you should add nodes by using add nodes. Okay, but the user is trying to insert a new node in an empty list. Okay, in that case, how will we check that? You have to check whether head is equal to null. If head is null, then it means that the list is empty. Okay, then just you have to make head to point to the new node. That's all. Just you have to make head to point to the new nodes, and the new nodes next will be null. Okay, so that is case 1, right? Then case 2 is, assume that I want to add immediately after the first node. This say there is new node, say there is a new node 25, which I want to add after the first node. Okay, then what will be the logic? then the first node's next pointer should point to the new node, okay, and the new node's next pointer should point to the second node, okay. First node's new pointer should point to the first node, sorry, first node's new pointer should point to the new node, first node's next pointer should point to the new node, and the new node's next pointer should point to the node which was previously getting pointed by the first node, okay. So basically even though even though the logic for adding after first node and adding somewhere later part seems to be same, but there is there is a little tricky part involved here, okay. There is a little tricky part involved here. The trick is so that we should separate this code, okay. The tricky part is that what will point the first node? First node is not pointed by any node, rather first node is pointed by a pointer. What is that pointer? We call it as, which pointer points to the first node? Head is the one which points to the first node, okay. Head is the one which points to the first node, okay. So here what we should so if you want to add a node after first node, okay, if you want to add a node after first node, right, then how the logic should be written? Then whatever the new node that you are creating, that new node's next should point to wherever head's next is pointing. Head is nothing but first node. Wherever first node's next is pointing, there the new node's next should point, okay. There the new node's next should point, okay. And okay, and the head node's next, okay, and the head node's next should point to the new node, and the head node's next should point to the new node, because head node refers to the first node. The first node should point to the new node, okay. So this logic is slightly different from this particular logic, okay. So there are three cases we have to code separately. One is inserting at the beginning, okay. If the entire list is empty, then what is the logic for insertion? Just make head to point to the new node and new node's next is null, okay. That is first case. Second case is inserting after the first node, immediately after the first node. If you want to insert immediately after the first node is referred using head, okay. The new node's next should point where head's next is pointing, okay. New node's next should point where head's next is previously pointing, and then head's next should point to the new node. That is for the, in the case of inserting immediately after the first node, okay. If anywhere else if you want to insert, okay, then just to move on to the node which is previous to the just move on to the node after which you want to insert. Just move on to the node after which you want to insert, and this new node's next should point where the previous node's next is pointing, and the previous node's next should point to the new node, okay. That's the logic. Fine, let us understand this through the code, okay. And another important thing here, you see this function takes two arguments. One is the data part of the new node that is to be inserted, okay. When you add a new node, that new node will have a data part, okay. That we call it as new val, okay. Another is after which node you want to insert. You want to insert the new node after some other node, right? What is that node's data part? That we call it as after val, okay. So new val represents the new node's data part, and after val represents the data part of the node after which you want to add the new node, okay. So how can we call this function then? If I want to add a new node after node 3 and before node 4, and if the new node's value is 35, okay, then how should I call? Then I should call something like this: insert insert 35. 35 is the new val, that is the value of the new node, okay, and it should be added after the node whose data part is 3, Okay, this is how we can call, right? Okay, so this should insert a new node after third node, and this new node's data part will be 35. Okay, and then this new node will point to the node whose data part is the value 4, and that node will point to the node whose value is 5. Okay, data part value is 5, right? After inserting, we can display to check whether the insertion is done properly or not. So the display function which we have already written, right? Okay, now we called insert with these values. Let us plug in this to this function and check how it behaves. So this is what, so this is 35, this is 35, and this is 3. Okay, here also we create two pointers, traverse and temp. Temp is for the new node, so we create a new node. Temp is equal to struct node star malloc size of struct node. So this will create a new node. Okay, let us assume this new node's address is 6000. Okay, or say 8000. Let us assume this new node starting address is 8000. Okay, and this is being pointed by temp. This is being pointed by temp. Okay, this is being pointed by temp. This is being pointed by temp. Okay, so temp contains 8000, which means that temp is pointing here. Okay, and what about our original nodes? So node 1 is pointing to node 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 5. Okay, this is 1, 2, 3, and 4 and 5. Okay, so node 1, 2, 3, 4, and 5. So the last node is pointing to null. I'll represent using a cross symbol. Okay, so its data part is 1, this is 2, this is 3, this is 4, this is 5. Okay, let us assume the starting address of the first node is 2000. So head will point to the first node, so head contains 2000. So head contains 2000. It means that head is pointing to the first node, right? So all these are already there. Okay, fine. So with this knowledge, let us go through. Now what we do. So after creating a new node, and temp is now pointing to the new node, then traverse is equal to head. That is, traverse will also point where head points. So so that is, traverse is another pointer. So traverse is equal to head means what? Traverse head is 2000. So 2000 is assigned to traverse, which is nothing but an address. So it means traverse is pointing to first node. Traverse is also pointing to the first node. Okay. Then what we see, if traverse is equal to null, this is the case if the linked list is empty. If the linked list is empty, if it is totally empty, then you have to follow this. Okay, if it is empty, assume that there is no node in the list. When traverse will be null? When head is null. In that case, if traverse is null, then what we are doing? Head is equal to temp. Whatever the new node we created, that we are making head to point, because there is no other nodes, only this is the only node, and we are saying temp arrow next is null. Temp is this node, its next will be null, obviously, because there is only one node. Okay, so that is the case if the list is empty and still you are trying to insert, right? And this else if is the case if there is one node in the linked list. Sorry, not one node. If you want to insert immediately after the first node. Okay, if traverse arrow data is equal to after val. What is traverse? First node. Currently traverse is pointing to the first node where head is pointing. If traverse arrow data is equal to after val, what is after val? That is the node after which you want to insert that node's value. In our case it is 3, and the traverse arrow data value is 1. Okay, so in our case this is not the position, but say that this is 1. If this is 1, then it means that the new node should come here. In that case the new node should come here. Okay, and new node should point to 2 and node 1's next should point to new node. Then how we will do? Okay, then what we do is temp arrow next is equal to head arrow next. This is temp. Okay, new node only we call it as temp. In our case, new node is nothing but temp. Okay, we are not using the term new node in the program, rather we call it as temp. So temp arrow next is equal to head arrow next. What is head? Or instead of head you can also use traverse, because both head and traverse are pointing to the first node only. Okay, so head arrow next is, this is head is pointing to here, head arrow next is this node, so it means its starting address. If its starting address is 3000, then temp arrow next will point to 3000, so it means it will point here. Okay, now temp arrow next is also pointing to the second node, and head arrow next is also pointing to the second node, but actually you should make the head arrow next should point to temp. So next you have to write, this is not head, I'm sorry, this is head arrow next. Okay, this should not be head, this is head arrow next, either head arrow next or temp arrow next, sorry, traverse arrow next, whatever it may be, because both head and traverse are pointing to the same location. Okay, so head arrow next is equal to temp. What is head arrow next? This is head arrow next, and that will be equal to temp. It means this is pointing here, so it means no more this is pointing here. Now this new node is inserted. Okay, see, this order is important. There are only two statements, but this order is important. First you have to write temp arrow next equal to head arrow next. First you have to set this pointer, and then you have to change this. If you do reversely, then what will happen? If you first do head arrow next equal to temp, then head arrow next will point here, then this pointer is not there, then we don't know how to connect to 2, then you don't know how to make this new nodes or temps next to point to 3000. Okay, so first generally first always the right side part should be done. Okay, or you have to check before doing in which order you have to do that. You have to check very consciously. So that is actually one of the key things which you should understand when you are programming linked list. Okay, it is not that in any order you can do, no, only in some order it will work. Okay, your understanding may be correct, but if you are not putting in the right order, then the link will not establish correctly. Okay, so here you see we made temp arrow next point to head arrow next. When you make temp arrow next to point to head arrow next, both were pointing to the third node. Okay, but later you want to make the first node to point to the second node, so then you have to write head arrow next equal to temp. The moment you say that, this is no more pointing to this third node, now it is pointing to the second node, right? So this order is important, right? Okay, so this is for case 2. This is for case 2, that is when you want to insert somewhere immediately after the first node. Okay, the next case is if you want to insert anywhere else. Okay, then what we do, else, this is the else part, while traverse not equal to null. Okay, assume, so currently we want to insert we want to insert after node 3. Okay, so this is the new node which is being pointed by temp. Okay, which is being pointed by the pointer temp. So temp is pointing to the new node. Temp is pointing to the new node. Okay, then while traverse not equal to null, what we do is we check if traverse arrow data not equal to after val. Okay, after val is the node after which you want to insert. So currently what is traverse? Traverse is pointing to the first node. You see whether first node is equal to null. Well, first node is not null. If that is the case, you check if its data is equal to after val. What is its data? Its data is 1. Is it equal to after val? No, after val is 3. It's not. So this is not the place where we want to insert. Okay, let me delete this, otherwise it will create confusion. Okay, so if that is the case, then what should be done? Then traverse is equal to traverse arrow next. So now what will become to traverse? traverse arrow next is 3000. So it means that now traverse is not pointing to the first node, now it is pointing to the second node. Okay, say the second node starting address is 3000. Again we check whether traverse not equal to null. Yes, it's not equal to null. Again check if traverse arrow data is not equal to after val. Yes, it's not equal to after val. After val is 3, it is 2. So again traverse is equal to traverse arrow next. Okay, now let us assume the next nodes the starting address is 4000. So now uh, previously traverse is pointing to 3000. Okay, now what we do, again traverse is equal to traverse arrow next. It means it is not pointing to 3000, it is now pointing to 4000. So this pointer is no more pointing to the second node, now this is pointing to the third node, this particular node. Okay, right? So then again we check, while traverse not equal to null, yes, still traverse is not null. If traverse arrow data not equal to after val, now if you see, is it not equal to after val? No, it's equal to after val. After val is 3, this is also 3. Okay, then what happens, this is not equal to, it is equal, so the else part will execute. Else part says break. Break what? Break the while loop. Okay, so it will come out of the while loop. But after coming out of the while loop, there are two things. The while loop, you may come out of while loop if you find a node whose data part is equal to after val, that is after which you want to insert the new node. Either if you have find that particular node, you will come out. That is first case. Okay, because of this break. Second case is you have traversed the entire linked list, but there is no such data which is equal to after val, but you have reached the end of the list, that is you have reached null. In that case also you can come out. So this coming out of while loop happens under two cases. Either if you have identified the right node after which you want to insert, or you have traversed throughout the entire node but you couldn't find that node which is to be after which to be inserted, but you have reached the last node, which means you have reached null. So there are two cases under which we may come out of the while loop. Okay, if you come out of the while loop because if you have reached the end of the linked list, then that you have to say that there is no such node which you are trying to find after which to insert. Okay, so we check here if traverse is equal to null, because if this is the reason, because as traverse become null, because of that if we come out of the while loop, then we say that there is no node with value %d after val, there is no such node, and we exit, we go out of the program. Okay, otherwise if this condition is not satisfied, then it means that previously you have broken the while loop because we found the node after which the new node should be inserted. Okay, again here also how to insert. So this new node we are calling it as temp, and this node after which you want to insert, that is called as previous node, this which is called as prev. So how do we do the insertion? Here also first you have to establish this connection. Okay, this is the first connection you have to establish, and then you have to establish this connection. Okay, second, you should not change the order. If you change the order, things will spoil. Okay, if you establish this connection first, then what should be the code? This node is referred as temp arrow next is equal to prev arrow next. Okay, right? So you can see here temp arrow, sorry, this is not prev, this is traverse, named wrongly. Okay, so our traverse is the one which is pointing to the node after which we want to insert. Okay, so temp arrow next is equal to traverse arrow next. Okay, so you can temp arrow next is equal to traverse arrow next. Okay, and then traverse arrow next should point to temp. Okay, traverse arrow next is equal to then temp, right? So this logic will do that, right? This is how we insert node to the linked list. Okay, fine. So this is how we insert. Then let us see delete. How can we delete a node from the linked list? Okay, so again if you go through the logic for deletion, see, we should identify the node which is to be deleted. Again, that can be identified by its data port. Whatever that value that is being held in the data port, based on that we can say that this node is to be deleted. Okay, so for deleting we need two things. Okay, say again, let us assume the same linked list with 5 nodes, 1 2 3, 1 2 3 4, okay, and 5. Okay, so these are the 5 nodes we have. This is node 1 2 3 4 and 5. Okay, say head is pointing to the first node, say this is head, say it holds the value 2000, it holds the value 2000, it's pointed to the first node. Okay, fine. So here what should we do? In the say we want to delete the node 3, this node should be deleted. Okay, so this val is 3, it means the node whose data port is 3, that node should be deleted. Okay, so how to do? In the sense, we need first using traverse you should move to the node which is to be deleted, using traverse you should move to that node which is to be deleted. Okay, so traverse is a pointer which will point to the node to be deleted. We should also maintain another pointer, previous should point to the node which is previous to the node to be deleted. Okay, that is this node. Okay, then what should we do? We should make the previous nodes next should point to traverse next. Okay, just we have to say that previous next is equal to traverse next. So it means that this previous nodes next is no more pointing to this node, rather it is pointing to the traverse nodes next. That's it. Okay, now even though the traverse node is also pointing to the node 4, but the link is broken. You can see here, head is pointing to 1, 1 is pointing to 2, 2 is pointing to 4, 4 is pointing to 5, which means this node is deleted. Okay, okay, and to further delete you can also include, because this is dynamic memory allocation. Okay, so we can say that free of traverse. Okay, free of traverse, because traverse is pointing to the node that is to be deleted. So when you say free of traverse, this memory will be reclaimed by the operating system. Okay, that is OS will take off this. That's it. So this is how we delete node from a linked list. Okay, but here for insertion we discussed 3 cases: inserting in an empty list, inserting immediately after the first node, and inserting anywhere else. Okay, here also the logic will differ slightly if you want to insert, if you want to delete the first node. Say the node which I want to delete is the first node. Say this is not 3, this is 1. In that case I want to delete the first node. Then what should be the logic? Then the logic is you have to simply say that head is currently pointing to the first node. Instead you have to say head is equal to head arrow next. That's all. What is head arrow next? Second node. Head arrow next is second node. So now we are saying that head arrow, assume first node, second node starting address is 3000. So head arrow next starting address is what? 3000. Now that will go into head. So it means that head is not pointing to first node, rather head is pointing to the second node. The moment you say head is not pointing to the first node, then it is deleted. That's it. Okay, so because this is isolated from the list, you can free it by using the appropriate free function. Okay, so this is how we, what you call, we delete the nodes, right? Okay, let us see the logic here. Let us see the logic here. Okay, the diagram is clumsy, let me delete it. So let us assume this is 3. Okay, we are creating some pointer node star traverse and star previous. Traverse is equal to head. So in our case, what is head? Head contains the starting address of the first node, which is 2000. So traverse also will hold 2000. It means that traverse is also pointing to the first node. It means traverse is also pointing to the first node. Okay. This is the case if you want to delete the first node. If head arrow data is equal to val, because this is the node which is to be deleted. Okay, that is if the head always points to the first node. So the first node's data, if it is val, then head is equal to head arrow next. Then we are making the first node to point to the second node and come out. Okay. Otherwise, if you want to delete nodes from any other location, okay, then what you should do, this logic. Okay. While traverse arrow next not equal to null, this is quite similar to that insert logic which we have discussed. Okay. So these are the nodes 1, 2, 3. This is the third node. This is the fourth node. Okay. This is the fifth node. Fifth node is pointing to null. Okay. Say this starting address is 2000. I will call 2k shortly. Okay. This starting address is 3000, 3k. Its starting address is 4000, 4k. And the starting address of this node is 5000, 5k. Okay. Fine. So here what we are doing, well, traverse not equal to null. Is traverse is pointing to the first node, it's not null. Head is also pointing to the first node. Okay. While traverse not equal to null, if traverse arrow data not equal to val. Okay, what is its data? 1. Traverse data is 1. Is it equal to val? No, it's not equal to val. If that is the case, then what we do, previous equal to traverse. We are creating another pointer here. We are maintaining another pointer which is previous. So what we say, previous equal to traverse, which means that previous will hold the value whatever traverse contains. Traverse contains the address 2000. So previous also will hold the address 2000. Okay, which means that now previous is also pointing to the first node. So as of now, 3 nodes pointing to the first node, head, traverse and previous. Okay. But then what we change, traverse is equal to traverse arrow next. So which means that now traverse will point to 3000. So no more traverse is pointing here. So traverse is pointing to the next node. Okay. And what is its value? 2. Okay. Right. Again go back here and check, while traverse not equal to null. Where is traverse pointing to? Second node. Is it null? No, not null. What is its data? Is it equal to val? Val is 3. Its data is 3. Its data is 2. It's not equal to val. Then again we say previous equal to traverse. So now previous become 3000. It means previous is not pointing here. Now previous is also pointing to the second node. Okay. Then we say traverse is equal to traverse arrow next. It means traverse is no more pointing here. Traverse is now pointing to the third node. Okay. And what is its data path? 3. Then we check, while traverse not equal to null. Is traverse null? No, it's not null. If traverse arrow data not equal to val, is it not equal to val? No, it's equal to val. Its data is 3. The value is also 3. Then what we do? Previous equal to traverse. Okay. Now where is previous is pointing? Previous is pointing to the second node. Okay. No. Sorry. If traverse not equal to data, if traverse arrow data not equal to val, is it not equal? No, it's equal. As it is equal, the if part will not execute. The else part will execute and it will break the while loop. After breaking the while loop, again we check why we have broken the while loop. Okay, there can be 2 reasons. Either you have passed through the entire linked list and unable to find a node with this value. We are checking whether that is the case. If traverse is equal to null, then it means that there is no such node with that particular value. So we say no such node with that value and we exit. Otherwise what we should do, just we should make previous next to point to traverse next. That's it. So we say that previous nodes next will point to traverse nodes next. So that means, what is previous next? This is previous next. This is previous next. This will point to traverse next is this. So it means you have isolated this. Okay. Now we can also write here, after this we can also write free of traverse, which means operating system will reclaim that space. Okay, so this is how we can delete a particular node from the linked list. Okay, so so for example, you can see here. uh, so uh, so I can now, sorry, where is the notepad? Yeah, so now for deletion I can just write here. What can I write? Delete of that particular node, whichever the node I want to delete, with the delete the node whose data part is 3. Okay, after deleting again we can display. So the node will be, again it will display, right? So if you want the full code we can copy here, copy from here. So first is what? First is this part. First is this part. Okay. Sorry. Let us keep the annotations. First is this part. Control insert. Okay, so first we should define this structure, right? So that part will come here. You should also write hash include stdio.h and hash include stdlib.h for defining for malloc, cloc, all those things. Okay, here we can say that initially when no node is created, obviously head should point to null. Okay, so we can write that here, and then adding, this is the logic for adding new nodes. Okay, so adding new node. Adding elements is that's it. It's just that that one slide. Okay, but here the closing bracket is missing. Then inserting nodes. So this is the code for inserting node. Inserting new node at a specific location. Okay, so here it is head arrow next. It is head arrow next, and this is the continuation part of insert. This is the continuation part of insert which will follow here. Then the deletion. So this is the deletion. The deletion part. Here also the closing bracket is missing. Yes. And then this is the logic for display. It's a very simple logic. Control insert. Yes. So this becomes the complete code, right? Okay. Fine. Let us discuss the execution of the code in tomorrow's class. It is not. So I think you understand what we are doing, right? Let us see this execution in tomorrow's class. Fine. Let us stop here. Thank you.